Hello everyone. So for this experiment, the overall safety precautions were the only two safety precautions I had to take mostly this time was to have insulated glove as well as the heating pad for shaking the ice because the bag got extremely cool. And for the second experiment, the only I think the risk was that to remember to turn off the stove after heating is done of the water at 100 degrees Celsius to the boiling point of water, and to carefully place the test tube into the hot water without burning yourself. So these were the two safety precautions I had to take. Other than that, the experiment was pretty simple. Uh, Wearing gloves and glasses, everything was straightforward. This is my three balloons. It's room temperature, cold, and hot. Now moving on to the results. These are the results for the ice cream. So the temperature of the Ziploc bag was 34 degrees Fahrenheit. I somehow for me, but I started calculating it in Fahrenheit because the unit was not given. So I'm not sure if I needed degrees Celsius or Fahrenheit. So the temperature went from 48 to all the way to 30. I think after 2 or 3 minutes, the temperature of the milk stayed 30, which is about roughly 0 degrees Celsius. That is a freezing point of water. Uh, it stayed there, uh, but milk became more viscous. It wasn't completely solid, and partially, I think the reason for this was because I didn't have 4 tablespoons of coarse salt. I had only 1.5 actually. I don't know. For some reason, the coarse salt amount that I got was extremely low. But I did try my best. I shake till my hands started aching, and the milk didn't become completely solid, but I could see it slowly turning into semi-solid. But I think it would have taken more than 10 minutes for that to happen. For the second experiment, this is the table. I'll put this table into the while doing the submission as well. So for cold, it was 12 degrees Celsius, circumference uninflated 23.4, inflated 35.1, hot 48 degrees Celsius, 23.7, and 33, and room temperature 25 degrees Celsius, 23.5, and 33.6 degrees Celsius. So if you look carefully at the energy activation diagram, this is what I came up with. So overall, I see there is so the EAC for cold, activation energy for the cold, was extremely low compared to the activation energy at the room temperature. Activation energy for the hot, I think it took some time for bubbles to come up faster. So this is my diagram. Here is a reactance. It was exothermic. Heat was given outside to the surrounding, and this is the product. Even though heat was given outside to the surrounding, we trapped it into these bubbles. Now, second part. I will show you the. There you go. So. Okay, I can't see my mouse. Okay. So this is the first one. This just shows the table, hot, cold, and room temperature. This is the bar graph of balloons versus temperature. I think you meant it to be a scatter plot if you want to have balloon circumference versus temperature. Not entirely sure how we could have bar graph where we would have balloon circumference as x-axis and temperature as y-axis. But I'll still put bar graph as well as the scatter plot and this diagram into my post while submitting the assignment. Now, for the critical part, explain why the temperature of the ice cream did not change. So, the correct vocabulary would be that by using the coarse salt, it maintains the temperature of the ice at freezing point. So, one of the examples I would like to give here is when I was a kid, we used to get this guy who used to who used to go around with a cart in which he used to keep his ice cream. And I always used to think that why wouldn't his ice cream melt, or the ice that he puts to keep the ice cream cold would melt. Partially the reason was that he was using coarse salt. So what coarse salt actually does is that it maintains it almost reduces, it almost kills, or makes the exothermic reaction, that is losing of heat of the ice, to zero. That is why the coarse salt is used mostly to maintain the temperature of the ice, and it is also used in fish industry to keep the fish fresh and store it in the ice. And why are enzymes common in biological organisms? Because enzymes are basically soluble proteins which speed up chemical reactions. So enzymes in our body are what they actually do is there are various types of enzymes. Some enzymes break down fat, some enzymes break down protein, some enzymes break down cholesterols. So yeah, without enzymes, I would think you eat one egg and it would probably take about, I don't know how long, but it would take a very, very long time for our body to break down that egg protein into something useful for our body. Enzyme just speeds up that process. And coming to the last part, the self-reflection. Yes, everything did go as I planned. Well, not exactly. Since I didn't have coarse rock salt enough, I think that is partially the reason why my ice cream did not become solid in 10 minutes. How did I troubleshoot? I couldn't troubleshoot because I don't know where to find a coarse rock salt. Did you apply laboratory skills you have honed? Yes, I'm pretty comfortable around lab. I can think of all the safety precautions and everything ahead of time and prepare myself. And does this week activities reveal any laboratory skills? Actually, nope. Except the fact that before starting the experiment, maybe I should have checked the coarse rock salt. Is it 4 grams, like 4 tablespoons of? Do I have enough coarse rock salt? That is like about 4 tablespoons. But other than that, I was pretty satisfied with this experiment. The second experiment was more fun because it successfully got executed. Ice cream was okay, so because of the coarse rock salt. And I think that's about it. Thank you.